So in this lesson, you need to be able to find two types of solutions. One are specific solutions where the directions will say find all solutions in the interval 0 to 2 pi. General solutions are something when you have to find all possible solutions. So again, if the direction says to find all solutions in a specific interval 0 to 2 pi, you'll just look at your unit circle and look for the answers there. If the direction says to find all possible solutions, then you have to account for all possible solutions, meaning including any coterminal angles. If your equation ends up being that in terms of sine, cosine, cosecant, or secant, your first step is to find specific solutions in the interval 0 to 2 pi. So first find all the solutions possible from 0 to 2 pi, basically your unit circle. And then what you do is you add 2n pi to each of your solution from step 1, where n is an integer. So integers are numbers like 0, 1, 2, -1, -2. And the reason you do this is because sine, cosine, secant, cosecant angles repeat themselves every 2 pi, right? Remember you can find the coterminal angles by adding 2 pi, or they're periodic, right? The period is 2 pi units. So if you were to add 2 pi, you would be just doing one full rotation in the positive or negative direction, and you would be accounting for all of the possible solutions. If your equation is that of a tangent or cotangent function, then you want to remember, just like when you're graphing, remember how sine and cosine were, period was 2 pi over b, whereas tangent and cotangent, the period was pi over b. So tangent and cotangent, since it repeats itself every pi units, what you do is you find the specific solutions from 0 to pi. All right, so that's one full period for tangent and cotangent graphs. So you look for the solution between 0 to pi, and then to each of your solutions from the step 1, you're going to add n pi, again, where n is an integer. So that would account for all the coterminal angles, or not just the coterminal angles, but all the answers that would give you, all the angles that would give you the same answer in both the positive and negative direction. Here's an example. It says to solve 2 sine of x minus 1 equals 0 in the interval 0 to 2 pi. So because it says in the interval, you want all the answers in a specific region here, specific interval here. This is going to be the specific case where you just solve for all the values that fall in that category. So 2 sine of x minus 1 equals 0. So I went ahead and added 1 and divided by 2. So I got sine of x equals positive 1 over 2. Now you look at your unit circle from 0 to 2 pi. Right, 2 pi is excluded, so you wouldn't include that as your answer. So in your unit circle from 0 to 2 pi, where does your y value equal positive 1 over 2? Okay, so that occurs at pi over 6 and 5 pi over 6. So your final answer would be x equals pi over 6 and 5 pi over 6. Again, what this means is if you have 2 sine of x minus 1 equals 0, the only angles that would fit in here that would make this statement true from 0 to 2 pi would be these two angles. Now let's compare that to this example here. It says to find all solutions of sine of x plus square root of 2 equaling negative sine of x. So you're looking for all the values of x that, if you were to plug into this equation, would make the statement true. The key word here is finding all solutions. Therefore, this is that second type where you're going to solve for general solutions. Now here, if I move things around so that I have just one trig function, so here I added sine of x on both sides, getting 2 sine of x plus root 2 equals 0. Then I subtracted root 2 and divided by 2, getting sine of x equals negative root 2 over 2. Right, so you want to, in the end, just get an equation where you just have a single trig function here. So now that we have it rewritten as this equation here, sine of x equals negative root 2 over 2, we have to do the following. Because we have a sine function, we're going to first, remember step 1 is to find all the solutions from 0 to 2 pi, because that would give you all the unique solutions possible. So So looking at the unit circle, you look for the locations where your y value, because it's your sine function, right? Where your y value equals negative root 2 over 2. Your y value equals negative root 2 over 2 at 5 pi over 4 and at 7 pi over 4. Now, if this equation said to find all solutions from in the interval 0 to 2 pi, that would be your final answer, 5 pi over 4 and 7 pi over 4. But because it asked you to find all the solutions possible, we have to account for all the solutions possible, not just from 0 to 2 pi. So remember, for sine, cosine, sine, cosine, and their reciprocal functions, cosecant, secant, you're going to add 2n pi. And if you have like tangent, cotangent, you're just going to add n pi. So I added plus 2n pi, or I included plus 2n pi to each of my solutions, and this is going to be my final answer. Here's an example that says solve 3 tangent squared x minus 1 equals 0. Do you think you'll need to find specific solutions or general solutions? Okay, in this case, you're going to have to find general solutions because they don't limit your solutions to a specific interval, right? It doesn't say solve this equation in the interval, 0 to 2 pi, that type of a thing. Okay, so I went ahead and added 1 divided by 3, and then I took the square root of both sides. Remember, when you're taking an even root of both sides, like the square root, you have to account for both the plus and minus. So I get tangent of x equals plus or minus square root of 1 over square root of 3, which is just plus or minus 1 over root 3. If you'd like, you can rationalize the right-hand side to get root 3 over 3, but in this case, it's actually easier to just keep it as this form here, because you're going to look at your unit circle and you're going to look for where your y over x gives you positive or negative 1 over root 3. Okay, so where in your unit circle are you going to look for this happening? Again, because we have a tangent equation, you only look from 0 to pi. Okay, you only have to look from 0 to pi because tangent and cotangent graphs are periodic, meaning they repeat themselves every pi units, right? So you only need to look from 0 to pi, so the upper two quadrants. So looking in the first two quadrants, right, because it's from 0 to pi, where does your y over x equal positive 1 over root 3? So I just went and separated the positive and negative. Okay, that occurs when when your angle is at pi over 6, right? Where do you get negative 1 over root 3? That's in quadrant 2, right, when the angle is at 5 pi over 6, okay? So that's not my final answer though, right, because we're solving for all possible solutions since they didn't limit your answers to a specific region. So we're going to have to add n pi, right, n pi, because we are accounting for all the periods, right? Pi, it's periodic, every pi repeats itself every pi, but n is like an integer, like -1, 0, 1, that accounts for all the different rotations possible in the positive and negative direction. So this is your final answer, x equals pi over 6 plus n pi, and 5 pi over 6 plus n pi.